So welcome everyone to the Potpourri. Uh, my name's Randy Atwood. I'll be the host tonight. We have a lot on the agenda, and I thought I would give a talk on the eclipse because this is the last Potpourri before the big event. So I thought I'd talk about what to look for, especially if who are plans to see it, and it'll be their very first eclipse. All right, so there are a few people here. How about second eclipse? Okay, that's good. Because your first total. Yeah, I mean, if you saw 10% partial, then good for you. Um, all right, so just a quick review. Why are there eclipses? The moon blots out the sun. When does the moon get in between us and the sun? Every month at new moon. So you would think there would be a solar eclipse every month, but there is not. Here's a nice, I like this one. It just kind of shows the shadow of the moon on the earth. The fact that the path it's pretty big, but it's usually you have to go and see one of these things. The rare aspect of this eclipse is it's in our backyard. So we don't see an eclipse every new moon, every month, because the moon's orbit is tilted 5 degrees to the plane of our orbit. And so I kind of like this. It's a busy diagram, but what it shows is that the unfavorable eclipse diagrams, the moon is either above or below the sun at new moon. And it's only when the line of the moon and the earth and the sun get all straight together, which they call the line of nodes, is when you have an eclipse. That happens twice a year, every 6 months. So there has to be at least 2 solar eclipses a year, 6 months apart, not necessarily total. But again, it's rare that you have a total eclipse in your backyard. So anyone who wants to see one usually has to travel. The big concern with solar eclipses is we don't normally look at the sun unless we're driving west near sunset, or that's usually why when it would happen. But if there is an eclipse, there's a reason to look at the sun. And the bright photosphere can damage your eye, the heat, the ultraviolet. It just doesn't do a good job on your retina. So we use solar filters. They normally give the sun a reddish look. So during partial phases, you use your solar filter. And generally, if you're looking at the sun and it's too bright, your brain is telling you, stop looking at the sun. But when it becomes total, then it's you can't see anything through your dark glasses. And that's the time when you just look directly at the eclipsed sun and the corona and everything. So a nice view of the interior of the sun, the different parts. It's the photosphere, the surface of the sun, that is the bright area where that light does the harm. And then above the photosphere is the chromosphere, where there's a lot of activity, like big prominences and things that we like to see during a total eclipse. A couple pictures from my friend Dr. Ralph Chu, who used to do this for a living, take photographs of damaged eyes. It's pretty rare. I've gone back through newspapers, and it's just usually a teenager just stares at the sun. It wakes up the next day and kind of has a dark spot in the middle of both eyes. And I find you really have to work at it to hurt yourself. It's when you start using optical aid like binoculars that focuses the heat. It's the old magnifying glass starting fires in leaves and stuff like that. That's where it gets dangerous. But everyone's been seeing these glasses, solar glasses. They're everywhere, and they're sold out practically everywhere already a month before the eclipse. Another way to view the eclipse is to project the image. I like using a pair of binoculars. You can use a telescope. You can also use, say, a kitchen colander to project pinhole images. But everyone nowadays have access to solar filters for telescopes. But 20 years ago, they weren't as available, but now they're everywhere. So for this particular eclipse, uh, a lot of us are traveling south to areas where the weather is supposed to be better. But it's passing through a lot of large cities. I think already the hotels are booked in Niagara Falls and they're going for $1,000 or some ridiculous price. And that's generally right across the whole path. A lot of the places are already sold out. But the weather is the concern, of course. April is not a great month. But I don't know. I'm a little optimistic. We're seeing some sunny days. Maybe the mild winter is going to give us a better chance of seeing clear skies. But generally, um, historically, the weather is better the farther south you go down towards Mexico. If you're near home, then you're going to want to either drive south into the US or down to the northern shore of Lake Erie or over towards Kingston to get into the path, because unfortunately we are not in the path. Um, we were going to set up an expedition of kayaks leaving from the Toronto Islands for this eclipse, but it'd be better in summertime, I think. But it's just amazing how close it did, in fact, come. The shadow leaves uh, the land just south of the Ford plant in Oakville and joins up again in Port Hope. But I think it would be an exciting thing to see from the top of the CN Tower, to see that lunar shadow cross the lake. And then moves out into the Maritimes, right through Fredericton, um, misses a good chunk of misses Charlottetown, misses most of Nova Scotia, and leaves Canada just off Gander and Buena Vista. All right, so what about this experience? Why do we go and see these things? Um, there's a lot that happens in a very short period of time. As you can see in these photos, the brightness is not linear, or the loss of brightness is not linear. For an hour or so, as the moon passes over the sun, you can look around, you won't see any difference. It's only the last 15, 20 minutes where things begin to get interesting. And I think that's really my favorite part of an eclipse, is when you notice that the light is changing color and the shadows are getting sharper and maybe there's a breeze coming up. It's just, we're definitely going to see something. We've been watching the progression of the moon through filters, of course. But it's at that point when things get kind of interesting. As you get very, very close to totality, the sun, instead of this extended orb of light, is now a slit in the sky, and it's very easy to make pinhole cameras with your fingers and project little crescents on the ground. If there were leaves on trees, you could stand underneath a tree and see millions of little crescents on the ground. Just a few minutes before totality, the shadow of the moon becomes visible. And I think I mentioned at the meeting a couple of weeks ago, this is really the only good picture I've seen of the approaching shadow with sunset colors before totality. This was in the Philippines in 1988. Just a few minutes before, or a minute or so before totality, once you see the approaching shadow, looking on the ground, you see these things called shadow bands, which is the interference of the light coming through the atmosphere, because it's just a slit of light and not a large ball of light or extended source. So at the last 30 seconds, things begin to happen very quickly. The shadow is beginning to overwhelm. And as you can see, I just found this the other day, and I think it's a great chart. It really gives you an idea of how quickly it gets dark and to what extent it gets dark. And so it's really the last 30 seconds or 15 seconds where You essentially are in a box and someone is putting a lid on that box. As the last little bit of photosphere disappears behind the moon, you get what's called the diamond ring effect. So the last little photosphere is the diamond, and now the visible corona is shows the actual ring part. And as the bits of photosphere break up into small beads, those are called Bailey's beads. And totality. Totality lasts 3 to 4 minutes for this eclipse, depending on exactly where you are. If you're near the center line, you'll want to look for the corona, look at the detail in the corona, look at the structure, look for prominences. Can't tell you how many prominences they're going to be because they're always changing. In the sky, Jupiter will be above the eclipse. Venus will be below the eclipse. All along the horizon will be sunset colors. And at this point, naked eye, no filters, binoculars, even if you have a small telescope, take advantage of doing that. As totality begins to end, you know it, because suddenly in the southwest, there's this big wall of light approaching. And when that wall of light reaches the moon, then the diamond ring starts and grows bigger and bigger, and the eclipse is over. Here's a nice view of the sunset colors during an eclipse, some of the prominences. Other things that can happen, reactions of animals. You might notice if you're near a farm, then you may hear roosters crowing, that kind of thing. So here's a video just to give you a sense of what the experience is like.
Yeah. 2 minutes. 2 minutes. Watch the light. Yeah. Everybody, look, it's getting dark up there.
There's the approaching shadow.
Shadow's coming. About 1 minute before. Michael, we're just going to get a little bit. We'll get some corona. Corona and prominence is right at second contact. "90 seconds. 90 seconds. Look at that shadow coming. Look how it's getting darker. There's a shadow. You can see the shadow coming. Yes. Everyone, move back so you can see up. Stay back. You can't see anything. You want to look up. Everybody, quiet. 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 Pretty quiet. 1 minute. 1 minute. Mark. 1 minute. Look for shadow bands. There they are. Look, there they are across the ground here. Look. You see them, Ben? They're going. Look, they're just sitting here and you're racing across the ground. You got them, Ben?
Very faint.
Yeah, look at them go. Shadow bands.
All right.
We have shadow bands.
Oh my God.
Look at the sunset colors already. Okay, ready? Remove filters on. Turn off. Oh, ready? Look at them, Betty. Corona, it says. Corona. I got Corona.
Oh my God.
Oh, wow. Oh, look at the prominences. Oh, my. Look at that corona. 1/500. Beautiful. Look at that prominence. Whoa. Oh, Betty, the video looks unreal. Side mounted. 1, 2, 3, 4. No stars, no planet. Look at the sunset colors. Beautiful.
So that's why we go and see them. So if it's your first time and you're thinking about taking photos, I would suggest that you don't. Eclipses don't really look like the photos. They're a lot better if you just see them with your eye. And there will be other eclipses that you can photograph. I would suggest that you set up a some sort of video camera or DSLR video camera on a tripod just to capture and frame it where you and all your friends are watching the eclipse. Capture the light levels, capture all the dumb things that you say. And it just, you can relive the experience because a lot happens in a short period of time. If you're in Mississauga and just outside of the path, I've been trying to figure out what 99.8% totality is going to look like. And I kind of think it's going to look like this. I'm not sure that you're going to be able to see Corona, just because when you take a picture, it sort of knocks down the dazzling aspect a little bit. I'm not sure, but for sure it's going to be a light show. Because it's quite possible that the diamond ring might just start on one side and just move to the other side as the shadow passes by. So it's going to get dark anyway, no matter what. And finally, if it's cloudy, it's still an amazing sight. My first eclipse was cloudy, and I'll never forget it because you notice the speed of the lunar shadow much better because the clouds sort of act like a translucent display, and you can actually see the line of the shadow moving by. And that's at 2,500 kilometers an hour. So it's pretty impressive. And if you're thinking about the next one, here's the next one in 2026 through Iceland and Portugal, Spain. And that is my presentation. Any quick questions? John?
Kind of answered the question already, but from Mississauga or other places just outside of that, 99.8. So I think those are actually seating.
I would doubt it. I think it's just going to be a very bright diamond ring. But the question is, it's only a diamond ring if you can see the corona. And I think it'll be dazzled. For the diamond necklace eclipse in '84, that was such that the moon just sort of was superimposed on the sun, but not just a little bit smaller, so that there were little Bailey's beads all around the sun. And people who just observed that with their eye, it was just too dazzling. But through a camera on the where you expose it, you're looking through the camera and everything. I saw corona, I saw prominences, because it was just, I think, going through that process, it affected the way it looked. It just knocked down the dazzling aspect a little bit. I think for the few seconds when at maximum eclipse, I think you're safe to take a look. And I think your brain, once it gets bright again and too dazzling, then you will look away and you'll get your glasses back on. But I mean, it's the kind of thing where I've never seen one like this before, so I can't really say, but a 99.8% eclipse, for you to look at it with your naked eye for 10, 15 seconds, it's not going to be harmful because you can do that with the regular sun. The only concern I have with nearby events is I have no idea how busy the QEW is going to be, but I have a funny feeling it's going to be a parking lot. I would not be surprised if the OPP close it at some point. But then you can get down to Oakville by just going down to Lakeshore and scooting across Lakeshore. But just be aware. I mean, we contacted the various emergency divisions for the different regions a year and a half ago. And Niagara did a great job in putting together a document which went all through that. And then they just distributed that document to all the other regions. So I think the OPP is aware of the day. And I know in Ohio and New York, they're having first responders at different places all along the highway because, you know, if you can't move on the highway, then yeah. So it's what they saw in 2017. And the data point that really gets me is that they determined that all of the cities and towns along the path in 2017, their population went up 50% on eclipse day. So once you introduce that number of cars, people, whatever, it just overflows everything. Yeah, it's like the way they used to, the old refractors, you'd get a little solar filter and you'd screw it into your eyepiece. And yeah, I know someone who was looking through it one day and went, boy, that's awful bright. And the glass had cracked. Yeah. Yeah. No, I mean, you hate to say, okay, yes, you can do this or you can't do this. And just if you're in a total eclipse, use binoculars, otherwise don't. I mean, but it's anyway, yeah, this is a long discussion. Yeah, Chris?
Alrighty. So as Randy mentioned, I'm a meteorologist at the Weather Network, and we know that there's one thing that everybody is absolutely petrified of on April 8th, and that is cloud cover. Randy did show a similar map looking at historical cloud cover. And so, as he kind of mentioned, when you go down towards Texas, into Mexico, and a little bit more in the southwest, that's where we have the best potential from a climatological perspective to have clear skies. As we start to head up into the US Midwest, that cloud cover percentage increases. And then as we can see, those grays over top of Ontario, Quebec, and in through Maritimes and Atlantic Canada indicate that we have a higher potential of cloud cover. So that's unfortunate. That is how the month of April goes. But we can also get a varied amount of different weather as well, from thunderstorms and tornadoes down in through Texas and the US Midwest to snowstorms, rainstorms, et cetera, in through the rest of Canada. So it's definitely something you want to keep an eye on the weather leading up to it, but we know that cloud cover is definitely the most important and sometimes can definitely be quite difficult to sort of get a handle on ahead of schedule. So I'm just going to bring this up here. And so we saw that map that talks about historical cloud cover. And this here is a snapshot of April 8th from the past 23 years. And what we're really going to see is it'll play through rather quickly because it's 23 images in about 10, 15 seconds, is no April 8th in the past 23 years has been similar across Canada. So you've got days where it's full-blown cloud cover, full-blown sunny skies, and everything in between, because that is what weather is a little bit of everything. So here's a look at it. We can see that it's quite variable. Some years we've got cloud cover in Ontario, sometimes we don't. And across the eastern parts of Canada is very drastically different from year to year as well. But everybody wants to know what's going to happen this year, because nobody cares what happened last year or the year before, because what didn't occur on April 8th was an eclipse the past 23 years in Canada and a good chunk of the US. So what everybody is going to wonder now is, how can I figure out if it's going to be cloudy where I am? And also, when can I start looking at this information and trust it? And the easiest answer that I can give at this point in time is, if you're looking at a cloud cover map now that somebody forecasts or just an image, it is wrong. Flat out. We are a month away. We're, April or March 8th now. So I won't name any names, but there are agencies that have actually issued their first cloud cover forecast for April 8th today, which is just going to end up being 100% wrong. So the question is when can we start actually looking at cloud cover and trusting it to sort of get an idea of where we need to go? So one thing that has sort of happened in the past couple of months, very new, and I'm sure they kind of rushed the project because of the eclipse, And that is, there's actually models out there, one at this point in time, that will actually do an 810-hour cloud cover forecast, which equates to, a couple of days ago, we were getting April 8th. So pretty well almost a month in advance. And this is the only model that actually does it. Now, here on this map, if we actually look at it, happen to scroll it right to April 8th at 2 p.m. in the afternoon, the blue in this map on the legend actually does not indicate that you're clear. It indicates that you have cloud. So a little bit sort of counterintuitive, to say the least. So these models, what they really are is more of a statistical and historical aspect of it with some initial conditions in it. So it looks pretty similar to, for the most part, other than Texas there, what a historical map would look like. So you're going to start to see some of these images pop up over the internet over the next little while, because we saw our first one a couple of days ago. And what I would say is, don't even take them with a grain of salt. Don't even look at them. If you want to look at them, you're going to absolutely have a horrendous month, because you're going to have some roller coaster ride for sure, and you're not going to be buckled in for it either. So take them with a grain of salt. And then the real question is when should we start paying attention to it? And I'll do a quick little shameless plug here. But we do have a hub page at the Weather Network that is everything about the solar eclipse. And it's got a bunch of information. And what we are going to be doing is putting some videos up here as we get closer to the eclipse with cloud cover forecasts. Whether you're getting it from the Weather Network or any other meteorologist, the main thing is to find and follow your trusted source with information leading up to the event. Don't trust those single images that you're seeing on the internet, especially in the month of March. When we look at sort of how accurate cloud cover forecasts are, when you go beyond that 7 and 10-day forecast, we're dropping below 50% accuracy rate. So you can kind of do a little bit of a coin toss at that point in time, and you're going to be probably, just as accurate as some of those models. So what we really want to do is look at, a couple of days in advance. My team and I will be putting out a forecast 7 to 10 days in advance. Very broad initial forecast, looking at sort of, do we have any weather systems coming? Because we know if we have weather systems, we're going to have cloud cover. So that's sort of the things that you can sort of look at your trusted sources. And then when we start to get closer to the event, start putting some stock into it on the Thursday and Friday in advance. So that's when we'll start to actually have better accuracy chances. And that's when you can kind of go, I know there's a group here heading down to Texas and sort of traveling along. You can start to make those decisions on that Thursday and Friday. Do we need to go all the way down to Texas? Can we go to just Indiana? Can we stay in Ontario? Do we need to go to Quebec, New York, etc.? So those are types of those questions that you can make that call as you're getting into that Thursday, Friday, and then refining that more so on your Saturday and Sunday. Now, one thing that I wanted to take you through is what you can do the day of, because we know the day of the event is very stressful, not just for us meteorologists going, okay, is there going to be cloud cover? Are we right? Because we know that out of a 24-hour period, we can sort of put out a cloud cover forecast, but 2 minutes to 3 minutes and up to 4 minutes matters. And that is it. It could be blue skies all day, except for that 4-minute period, and it ruins everything. And that's sort of the most important aspect of it. So one thing that I wanted to take you through, and I'll pass along these links as well, so that you guys can look at this information ahead of time and also leading up to it and the day of. So satellite imagery is really good the day of to make a decision, more so in that sort of, do I need to move 50 kilometers to the east? Do I need to go 200 kilometers? Where exactly should I kind of go? So this is a really good link here. It's called College of DuPage, and it's satellite imagery. It's going to tell you whether there's high cloud, low cloud, clear skies, even over up here and through southern Saskatchewan. It'll even pick up on snow as well. Hopefully we don't have snow in April, but anything is possible in Canada. So just sort of taking you through this page a little bit, and the other pages you'll want to play around with over the next 30 days to sort of familiarize yourself with it, because it's going to be really important the day of. But on this specific page here, you can get different views. You can look at your continental, your regional, and even your localized. So if you happen to be in Ontario, and it's taking a little bit of a guess here. The internet isn't the fastest. I won't try that again, just because it's a little bit slower, but you can get sort of zoomed in croppings. So you can kind of see how the clouds are moving as you play through this scroll bar. So you can see, is the cloud coming into Ontario? Is it moving out? What kind of movement do we have? And also what type of cloud? One thing that you'll notice is there's a heck of a lot of white here. And this is no way of prediction for next month, but we have all this really bright white cloud there. That's really thick cloud. You're not going to see an eclipse through that. Whereas over top here, you can kind of see a little bit, let's say over Niagara, a little bit of sort of grayish tinge there. And that's a little bit of high cirrus cloud. So these are sort of different features that you can pick out on radar. You can still see the eclipse through some high and light cirrus cloud. It's not going to be as great as a blue sky day, but it will kind of it'll be better than if you're in full-blown cloud cover. So if you need to move a little bit, this is a great tool that you can use to then look at, to kind of move throughout the region that you've picked a couple of days prior to get to. So as I mentioned, I'll pass along these links. There's 2 other sites that are available, many others as well. So kind of pick and choose which one you like, play around with it, but also familiarize yourself with a couple different ones. The reason why that is because come April 8th, there's going to be millions of people on this specific page. In 2017, if you thought that it loaded slowly here, it took about 5 to 10 minutes to load the image, and it wouldn't really even play sort of on the slider. So if one page is sort of bogged down, you can try another and kind of move throughout them. But it's definitely a good, useful tool to sort of the next little while to sit there and go, if I'm in Mississauga, what does this kind of little cloud do to my imagery there? So you can kind of learn over time how to look at the satellite image and how it's going to impact your view as well. Not sure if there's any time for questions, but if not, you can come see me during the break. And
Yeah, that would be great.
well.
Actually, talk to Matt during the break, and we'll get those links and put them on the email list.
Yep, that's true. We saw that with the 2017 eclipse and also the last annular eclipse, where you could actually track the weather stations showing a dip in their temperature. You can also see on satellite as well. So it's a kind of a cool feature. If you're in Ontario, you can see the shadow of the moon track it across it as well. So if, let's say, you have cloud cover, you can see that white. You've got sort of a shadow over top of it, so you can track that as well. But it does sort of reduce temperatures, stabilizes the atmosphere. And if there are thin, not overly developed clouds, it can help to dissipate them. If it's got cumulus clouds, it's not going to dissipate it, but it can kind of improve things slightly. But I wouldn't bank on it. Yeah, good. That is a good question. It's not too early, unfortunately. I just spoke with a friend from the BC Wildfire Services, and they're a little, scared for the early part of the season. April's a tad early. Now, unfortunately, Texas did have one, I guess it was about a week and a half ago. If you're really close to it, the smoke's definitely going to be thicker. The further away you are from the wildfire, treat it like cirrus cloud. It's kind of like when you see the sun anyways, when you have wildfire smoke, like what we did last year. It's going to dim it. You're still going to see it. The thicker it is, you wouldn't see the corona, because it'd just be a little bit too dark. Yeah.
So this is showing that I'm having fun watching them. There are three different types of solar filters. There are white light. There are 3 different types of solar filters. These are 3 different specific colors or materials that they use for white light solar filters. And again, the difference there is primarily just the resulting image color that you get. Oops, sorry. The newest kind that is becoming somewhat more common are calcium K filters. They are, I think, basically it's picking up on one spectral frequency, calcium K. It is more useful. This is more useful for photographic work because most people can't see or aren't that sensitive to the frequency. It's fairly a little almost outside of human visual range, but for photographic work, it's good. And it shows you a different, the white light filters that I showed you first simply work by taking down the intensity. It's down to about 1,000th of 1% of the actual light gets through, or to less, somewhere up there to even less. Whereas calcium K and the other kind, which is hydrogen alpha, operate by just letting one specific frequency of light through. They also generally, if they're included with telescopes, they also have to take down the intensity even further. But so calcium K is the calcium K line. It's the difference between it and hydrogen alpha is that calcium K is a little lower in the atmosphere. So you do see somewhat different features. But our big favorite in the club is hydrogen alpha because we have a hydrogen alpha scope. And Shaquille's going to talk about that and show you some of his stuff. And the key there is you've all seen the spectrum of the sun and how there are these little lines where things are absorbed. But in fact, in the case of hydrogen, hydrogen has a whole bunch of specific, very bright lines, and hydrogen alpha is one of the particular frequencies that you can choose to focus on. And the difference between white light and hydrogen alpha filters are specifically with our type of hydrogen alpha filter is that it's tunable, so that you can, by tuning it, you can look at different features of the solar surface, either the limb area or the front facing portion. And I just wanted to show you quickly, that's why I turned the lights on, John, a couple of I can do this, really. Maybe I don't need to show you this one. So this filter, I actually made our former treasurer in 2011, I think, had made a solar filter, and he had some leftover material, which he gave me. And so you can actually make your own. This one cost me about $1 for the white cardboard around it. And you can see that you don't need the full diameter. This is for one of the club Dobbs. So that's an 8-inch diameter. You don't need the full diameter if you're looking at the sun, because the sun's a fairly large object. I just have that as a protective thing, so I don't destroy the filter. And so that's an easy way. You can buy these sheets of solar filter material for $50, something like that. Or you can go ahead and buy a ready-made glass, I think. This is for a scope that was donated recently. Very dirty, but you can see this is much safer. With this one, I have to put tape all around it to make sure it doesn't come off at a really bad time. Whereas this one has screws. I would still tend to tape it on, but anyway. So again, these are some strictly white light, so we're just reducing the image intensity, the brightness. And that's it. No questions, I assume.
At Christmas, this was found underneath my Christmas tree, and it was given to me by my son's partner, girlfriend, whatever. So bonus points there. Yeah, she's a keeper. So this is the title of the book is The Origin of Time. You can see it up here. Stephen Hawking's Final Theory, and it was written by Thomas Hertog. How many of you have this book on your shelf? How many have read the whole thing? You're brave. How many understood all of it?
Every word.
All righty. Thank you, Alan. Yeah. Yeah. So if you had trouble with that book, I highly recommend this one. So it's written by Thomas Hertog. He's a cosmologist. He's got a doctorate from Cambridge, and he was a close collaborator. There's a new word for me today, obviously. A close collaborator of Stephen Hawking for 20 years at Cambridge. And he is now currently a professor of theoretical physics at the University of Leuven in Belgium. So how did this come about? 1990s technology advanced enough that we could answer some of the most incredible questions. And this one, the Cosmic Background Explorer, gave us this. And we have subsequently got better ones with the WMAP and the Planck satellite. But this changed everything, because what we're looking at here is as far back as we can go. This is the beginning of time, because we can't see further because light didn't exist before that. So because of that, we got some big questions. So why is the universe so bio-friendly? Kind of like asking a very different way of asking the question, why are we here? And there's neat things like he covers in the book. You make small changes in basic physics, like gravity. Gravity is a pretty weak force. You make it just a little bit stronger, stars would be bigger, shine brighter, and blow up as supernovas far before anything orbiting that star would have a chance to evolve life on it. The variations in the cosmic background radiation, that thing that from the previous slide, are 1 in 100,000. So it's very minute variations in the temperature of the cosmic background radiation. If you change that so it's just 1 in 10,000 difference, most of the structure of the universe would have just evolved into black holes and gone away. And here's another neat one. A neutron, I did not know this till I read the book, but then I didn't pay it much attention in university physics and chemistry. Physics, the big problem with me with physics was it was 9 o'clock in the morning, Monday, Wednesday, Friday. Things happened the night before that made physics a very hard topic for me. But a neutron is slightly more than the mass of a proton. If it was reversed, then the proton was slightly more massive than the neutron, then all the protons in the universe would have decayed into neutrons shortly after the Big Bang. And the book goes on. You can go on for pages of things happened that allowed us to be here. And then we had a paradox. If physical laws determine how the universe started, what existed before the start of time? Before the beginning, was there a beginning, or was there something there, or was there nothing? We have a hard time in our human brain imagining nothing. Although if you look at me on the couch on a Saturday, you can see pretty well the demonstration of nothing, or at least Newton's law of motion of an object at rest. So, like William Paisley, 18th century clergyman, said, like a watch, the design of the universe must have a designer. And then along comes this guy called Darwin, and his theory of evolution, that it's a natural process of random variation and natural selection that created the apparent design. It happened all on its own. Could this evolutionary idea be applied to the origin of the universe? The answer is, of course, yes. So the book then goes into the theories. The first theory it discovers is the no boundaries theory. It was first proposed in 1983 by Stephen Hawking and another cosmologist, Jim Hartle. If you look at, follow just relativity, Einstein's marvelous gift to us, and you take the universe back and compress it back to its beginning, you get a quantum singularity that is infinitely warped space curvature and no time. Kind of weird. You can't measure it. You can't figure it out. It just goes beyond thing. But Hawking and Hartle argued that if you run the clock backward, quantum and mechanical effects, that fuzziness of quantum mechanics, would blur space-time and the direction of space-time from the vertical, from past to present, would rotate into an additional horizontal space exception and still fit all the laws of physics. So I drew a picture. If you look at the one on your left, that is assuming relativity. Universe compresses down and then poof, we leave reality. But according to Stephen Hawking and Jim Hartle, you get to the point and it's like this boundary that you reach where all the physical forces that we understand, all the states of matter we understand, go away, but you can still measure it and apply all our current laws of physics to. So the question was, before the Big Bang, of what was before the Big Bang becomes meaningless. You know, Stephen Hawking answers that kind of question. Of before the Big Bang, it's kind of like going to the South Pole and saying, well, what's further south? You know, you can't go further south. And there's the beginning. You can't go further back from that because it didn't exist and it could never exist. And the other part of the theory is the physical laws that we use to measure and understand our universe all started. So if you look at the bottom here, all the physical laws, this is at the bottom of the no boundary theory. And then as the universe went through its rapid inflation, we started getting gravity. And then the dark forces, dark matter, dark energy. And then the strong nuclear force split off. Then the electromagnetic force split off, and then the weak nuclear force split off, and then we have our current standard model. Anybody study biology? Does that look similar, very similar to the tree of life that Darwin wrote about? That's where the idea came from. So inflation is a key part of that no boundaries theory. So inflation proposes that the universe expanded very rapidly at an almost impossible to imagine rate. It is caused by a scalar field. The Higgs field is a scalar field. And what a scalar field does is it can generate negative tension, kind of think of negative pressure, and can cause anti-gravity. The no boundary hypothesis predicts that the universe was born out of a rapid inflationary expansion from that point where all the physical forces merged into one. And all the satellite from the COBE, the WMAP, and the Planck satellite data match that. This is a scan from the book. And this measures the temperature and angular separation of the cosmic background radiation and matches it to the theory of no boundaries and the inflation theory. And all those little dots are from the Planck satellite measurement. Fits pretty well. Fits the theory pretty good. And it also fits this one. You know, that 4% of the early universe was free hydrogen and helium, a little bit of lithium. Rest of it was dark energy and dark matter. And as we were talking, Dennis and I were talking earlier, we don't know what it is. Lots of theory, but we don't know what it is. So that fit theory has been the no boundaries theory has been pretty well supported. So then we needed a change of thinking. Since Archimedes was around, we've been formulating thought as observers of an isolated system. So we set up an experiment and we watch how the experiment goes. We are separate from the experiment. Problem is, we're in the universe. We can't separate for ourselves from the universe. The observer is part of the equation. Stephen wrote his book, A Brief History of Time, from that God's eye perspective. And in 2002, in discussions with Thomas Hertog, he said, the failure to recognize this has led us down a blind alley. That's to recognize that we are part of the universe and we are within what we are observing. We need a new philosophy for cosmology. And then all of a sudden, a whole bunch of stuff started happening. Cosmology, up until the 21st century, has been focused on bottom-up thinking. How did we start? How did the universe start? But Hawking and Hertog and the group at Cambridge said, well, we can only start from the present we know and work backwards, a top-down approach. But this conflicts with quantum mechanics and quantum field theory, because if the observer causes the probability field to collapse, remember Schrodinger's cat? So how do we reconcile this? So the book goes in and it covers all the very interesting cosmologists through time that have helped get us to our current understanding. It talks about people like Georges Lemaitre, the Belgian priest cosmologist, who came up with an interesting discovery in 1927, that if you took the newly discovered expansion rate of the universe and run the universe backward at that same rate, the universe would only be 1 billion years old. So that was interesting. So in the 50s, a gentleman named Hugh Everett managed to break down the wall between the quantum micro world, how we work in the small world at the atomic and subatomic level, and the classical physics macro world. He came up with a theory that there is no collapse of the waveform or the probability field when you're observing it, that the whole universe is only a single wave function. The wave function includes us as the observers and everything in the universe. The waveform evolves gently and smoothly, and it explores all possible pathways. So this new cosmology that Hawking and Hertog and cosmologists were working on was one that could combine observers, asking questions, the boundary conditions at the origin, and how it all evolved. And they're all interrelated. In the 1970s, John Wheeler, very interesting character. If you ever want to see an interesting out-of-the-box thinker, this guy was it. So he proposed that a quantum universe is kind of a self-excited environment. So if you look at this U-shaped drawing, the universe starts small at the upper right, and then eventually expands until you can have observers, sentient life that can observe and look back, and they can bestow a tangible reality on the past. Whoops. Let me go that. So we end up with something that looks like this. That's our eye. We're the eye in the middle, and we're looking back into various different possible pasts and various possible futures. And this required another idea, holographic thinking. Now, this one I had a hard time wrapping my head around, but holography envisions everything in the four dimensions we experience, up, down, back, forward, the 3 dimensions of space plus time, is a manifestation of a hidden reality located on a thin slice of space-time. But sometimes I think it'd be better if I ate a couple of mushrooms and and read this stuff. So it's a different way of looking in the world from which gravity and warp space-time are somehow projected on it. And Stephen used this thinking to combine quantum theory and general relativity into the equation for black hole radiation. Up until that, black holes were thought to be a one-way trip. Stuff goes in, never comes out. But that means that all data and information is destroyed in there, and that violates physics thinking. So he came up, and basically Hawking radiation says that a black hole radiates like a black body radiation. So black holes are not bottomless hits. Then we get all these things that developed in the 90s and 2000s. String theory, which is 5 different theories of extra dimensions that are all curled up into 2 dimensions. And another one called supergravity, which if you extend Einstein's theory, that theory of relativity, and involve matter and supersymmetry, you get these membrane objects that were spread all over. Once again, mushrooms required. So this was combined by Edward Winton in 1995 into M theory. And that and it's important to remember that mathematical relationships that transform seemingly distinct theories into each other are known as dualities. It's okay, I'm almost done, Randy. So then comes an Argentinian gentleman named Juan Maldacena, and he connected the string theories with gravity theories with gravity to particle theories without gravity. The 2 sides in Maldacena's duality live in a number of dimensions. The particle theory is like a hologram of the gravity theory. So Maldacena said, we're kind of like this bowl of space-time. Gravity is on the inside, that's our universe, and whatever. And then on the outside is projected particles on the boundary of our universe. So Stephen and Thomas put it all together, and they came up with this conclusion that the universe is a 3-dimensional projection on an expanding 4-dimension hypersphere. So we can't imagine 4 dimensions because you know what? We live in a 3-dimensional universe. You know, the best expression I saw was a video where somebody said, it'd be kind of like somebody in a 2-dimensional world watching a sphere move through. The sphere would come through and start off very small circle and become a bigger and bigger circle and then shrink and go away as it moved through. That's the closest we can get to. So stars and galaxies, matter, us, we're all piled up near the boundary surface on it. And you get this picture. And that's how they draw it. And it looks like something out of medieval art. But I'm going to read the description with that. And it says, to get a grip on the quantum origin, the early Stephen of the 1980s conceived of the universe in imaginary time. Thinking in imaginary time, all dimensions behave as dimensions of space, 2 of which are shown here. The origin of the universe lies at the center of the disk, and it expands outward in radial imaginary time. Direction. The universe today corresponds to the circular boundary, so the circle around the outside of it. However, the later Stephen went further, much further, and took us from the imaginary time to no time at all. Exploiting the holographic properties of gravity, we came to envision the boundary of the disk as a hologram made of entangled qubits from which the interior space-time, our past history, projects down. Holographic cosmology builds in a top-down view, which the past, in some sense, is contingent on the present. So he somehow manages with that concept that says our past, which we can observe, is affected by us as observers. So you all baffled? Yeah, it's a good read. Thomas Hertog, his prose is excellent. He writes in a fluid and understandable manner. He keeps the mathematics to a minimum, and he takes us through a great journey of the 26 centuries of cosmology from Anaximander, who first proposed that the Earth was a ball of rock floating in space, to where we are now. So get the book.
Okay, so hi, everyone. This is actually my first face-to-face presentation. So I've done about 3 or 4 on Zoom. So it's a little different for me this time. I'll channel my inner Randy with a dash of Alan. Let me just get this out of the way first. We all have an inner Randy, right? Okay. So this is my experience on the August 21st, 2017 eclipse. There were a lot of great presentations after this, and I was just compiling my information for a while. And because I love public speaking so much, I had held off until now. But I titled this an unexpected journey because in many ways, I wasn't planning on attending this eclipse. Okay, so about a week before the eclipse, there were two friends of mine, really good people, Blair and Michelle. They said they were planning on going down to Salt Lake City and then driving up into the path of the eclipse. So with about a week to go, I said, why not? Let me just book a flight and join you guys. But then everything was booked at that time. So I took one for the team and flew business class, and happened to get myself onto a window seat, much to the chagrin of the flight attendant. And on the way there, this is over Iowa and Nebraska. I had my company iPhone and I noticed these anvil clouds. And so I've heard about these major storms in that part of that part of the country. So we were chasing the sun. I could see the horizon onto the right, so I could see the clouds and everything underneath. And sure enough, it just started lightning everywhere. And this lasted for probably about 2 or 3 hours. And it was just lightning storm, lightning after lightning. And I was just clicking away, further annoying the people around me. But I managed to capture quite a bit of lightning. And these are huge thunder clouds here, storm cells. So that was another unexpected part of my unexpected journey. So when we landed in Salt Lake City, the plan was to drive north, and we hadn't booked anything yet. There was nothing, no place to stay or nothing. So I guess the plan was to book it along the way. So Michelle was on the phone trying to book something through Airbnb, through anything that we could find. And the place that we decided to go to was Rexburg. And if you can see, Rexburg is just above the line, the center line. So we said, okay, let's look for a place in there. And we finally managed to find basically a plot of land. There was no house, no nothing. And we were charged, I think it was $80 to park our car there. So we're like, okay, so we booked it. We needed at least one place. That was the only place we could find. So when we got there, the plot of land was just enough to fit our car. And we had found out that the person that was booking the land had another plot right beside it. And there was a huge RV that had been booked into there. So we were like, okay, we might not want to stay here that night. And we decided to just check out Rexburg to see if there's any other sites that we could find. And right nearby was a huge Walmart parking lot. And there were campers and trailers all over the place. So we went up and asked them, how much you guys paying for your spot? They're like, paying? This is free. And there's a grocery store there. And the guy said we can use his washrooms and he's giving us discounts on all the food. And we're just like, okay, $80 down the tube. So then we decided to explore the area a bit further. And we went from Rexburg all the way down this highway to Driggs. And Driggs is a small little town there. We checked it out, nothing happening in Driggs. So we said, we're not going to stay in Driggs. So we decided to drive back to Rexburg. And on the way, we found this little spot here, the Teton Byway. And it's basically a little jug handle off the highway. So we decided, okay, we're going to be sleeping in our car anyway. We don't want to be around too many people, especially a huge trailer. So we'll just park here. And the main reason we parked here was the view. It was just a spectacular view. And you can see it was slightly raised. You see the Teton Mountains in the background. And the eclipse would occur just above the mountains, like straight up above the mountains. So we're looking, okay, we saw one other car there and we're like, okay, we're ready to stay the night. We'll just stay the night here. So we parked, we got out and we started exploring the area. And as night came, we just wanted to see if there were any dangerous wild animals around which might attack us at the nighttime. I don't know what we would have done if we found anything. But you can see that people did start to arrive as well. There's only 2 cars initially, and then we had a few more before we went to bed. And so based upon our thorough analysis, and the reason I chose Unexpected Journey, because that's the title of The Hobbit as well, because he goes into his all those little adventures. And hopefully we're not going to be slaying any dragons, but we found a few things that were concerning. So the night before the eclipse was a very interesting night. See, a picture tells 1,000 words. So it was very cold. If you ever have an idea of sleeping in the back of an SUV with the back seats folded down and you're sleeping on an angle with a comforter which has been borrowed from a hotel, I would not recommend it. It got very cold out there. Secondly, it was not very comfortable at all. It was very uncomfortable. And the third part about it was the fact that cars started arriving in the nighttime because they saw our car there and the other car there. So the whole night, there were these headlights that kept on waking you up and when you're actually half asleep, cold and whatnot. So it was a very interesting night. And to top it off, at about, I believe it was 3 o'clock in the morning, a huge Greyhound pulls into right beside our car. And out of the Greyhound comes about 30 tourists. And they're all, I believe they were Japanese. And they got out and they lined up their tripods and they were loud, but they were very excited about something. And I'm just trying to sleep and I can't sleep. And then after about 4 o'clock, they just left. I got out of the car. I said, I'm done. So I get out of the car, I wash up and I look out and I see the sky is just full of stars. I think it was like a Bortle 2 site. It was just stars everywhere. And what they were excited about was the fact that Venus was rising above the horizon and it was piercing brightness. So they were all taking pictures of Venus. And on the right side, above the mountains, were the Pleiades. And again, above me was the Cygnus area of the Milky Way. So I was just into photography. I had no idea what I was doing. So I just took some pictures. It's a little embarrassing, this picture, but you can clearly see in here the North American nebula. And beside the star, and Pelican is kind of visible, beside the star Deneb. And just on a side note, the star Deneb, the name comes from the Arabic Dhanab ad-Dajaja, which means the tail of the hen. In the Western mythology, I guess, Cygnus is described as a swan. In their mythology, it's a hen. So that's where the name Deneb comes from. And then if you look at the star down in the middle, it's known as, the pronunciation is Sadr. Sadr means breast, because it's the breast of the hen, the chest of the hen. So you can see the butterfly nebula there as well, and some of the other nebulae around there. So not a great picture, but I was quite pleased with it because I barely knew what I was doing. Then we have, for the first picture, it was a 50 mil lens. The second picture was the one I was going to use for the eclipse, which is the 180 mil lens. And I took a picture of the Pleiades. And the Pleiades, I didn't process this picture for 4 years after because I thought it was so bad. But 4 years later, I processed the picture. And then I take a look and I noticed something that couldn't be processed out. And it was this. And it ended up being a comet passing by the Pleiades. Comet C 2015 ER61 Pan-STARRS. So again, another unexpected thing and an unexpected journey. So the next morning, there was a lot of people there. People have been arriving all night, and there's a lot of excited people parked there, bleary-eyed, but very, very excited. And they started spreading out across the top of the ridge that we were on. We can see ourselves on the right there. This was from actually other people that took pictures and shared them online. And people had all kinds of lenses there, small scopes, but mostly telephoto lenses in their cameras, and getting some sun in before the eclipse. The night before, there were clouds. The day of the eclipse, it was crystal clear. And not only individuals, but families also were there as well in terms of all excited to view the eclipse. So my setup was my T5i camera, a crop sensor camera, intervalometer, 180 Nikkor lens with an adapter on there for taking a decent picture of the eclipse. Kendrick solar filter, white light filter. Sky Tracker Pro, which is a tracking mount from Ioptron, and a Manfrotto tripod, which are pretty solid tripods. So, in all my photography, planning is the most important thing. So my methodology this time was polar align the tripod before dawn. So all these stars that I saw, I made sure that the mount itself was fairly well polar aligned. Charge the camera battery and have a spare, always have a spare. And charge your mount because this tracking mount is either chargeable, or make sure your power supply or batteries, you have a spare there as well, and everything's fully charged. Also before dawn, focus the camera and tape down the focus ring because it gets crazy around the eclipse time. And this is my first eclipse. I know, Randy, you said don't take a picture on your first eclipse, but I couldn't help myself. So I taped down the ring. And because I've had bad experiences with mounts failing on me in the past, what I did was I got the mount going and I was running, but I moved the camera and the camera over towards the sun about a half an hour before, and then I turned on the mount because it was already aligned. Then I turned on the mount because I didn't want to waste the power. Crazy things happen. The one thing that saved me here, and this is what I wanted to do beforehand, was using bracketing exposures. So you can, these are the menu items on the Canon menu. So this allowed you to make sure that even though you got an exposure, if you got, this took 3 pictures every single time you press the shutter. And you could set it so it could be 1 stop down, 1 stop up. So for example, you shoot 1 2,000ths, it'll take a picture of 1 2,000, 1 1,000, and 1 4,000. So you got your range covered. So that helped a lot at the end when I was trying to picture, sort through all the pictures and figure out exactly what's the right exposure for each phase of the eclipse. And the last part, of course, was practice before eclipse, because this bracketing exposure will not work if you set your camera to single shot. You have to set it to continuous shot. That's the only way this will work. So through trial and error, I was ready to go. So as Randy described in his presentation, this is about 3 hours before totality. It became like a Martian landscape. It was like ruddy color, and the shadows became very distinct. And this is at the eclipse. This dark area on the top of the picture is actually the shadow. I saw the shadow coming. It was like a wave. So I had my camera. I took a picture of the shadow right here. And then as it whooshed around, I whooshed my camera around, took a picture. So you can see on the right top side there, that's the shadow there. That's the edge of the shadow as it flying by us. And on the left side is, of course, the part that's about to be covered. And then boom, we were under the shadow. And you can see the Teton Mountains there are not under the shadow yet. That's why they're still bright. But the rest of this area is just entering into totality. And it was spectacular. So I created a little bit of a time lapse. So all those shots, I sorted through all the pictures that I got, and the camera settings had changed throughout the eclipse. When it was in the partial phases, I used 1 4,000th of a second because, as Randy mentioned as well, it's very bright, and that was the maximum of the T5i that in terms of the shutter speed, the fastest shutter speed. When we got into totality, I dropped that down to 1 1,000th, and there you can see the prominences on the solar disk there, on the chromosphere. And then during the full totality phase, I varied my shutter speed between 2 seconds and 1/15th of a second. So I was going through and changing the exposures. And the reason was I wanted to get as much of the corona as I could. A lot of pictures are just like this, where they look at the actual inner corona, but I wanted to capture the outer corona as well. So this is a shot by, I think, Lauren Roberts here. And this is part of our group as well. She took an amazing picture here, a wide angle picture of the eclipse over the Teton Mountains. And you can see the red along the horizon. That's what everybody was talking about. It's like a full 360 sunset. And as you mentioned too, the birds and the animals started acting funny. So down here, the birds started circling, and there were some livestock or cows, and they sat down. So it was a glorious 3.5 minutes. And then as it was over, people started getting the heck out of Dodge. Within half an hour, everything was basically thinned out, and you can see the sky was back to normal as if nothing had happened. But and one of the people that was there with us took a picture of us gathered there on that ridge and posted this on Google Maps. So when you go to Google Maps, you could see this picture for a while of all us gathered there. So we also formed we formed a good a bond, a fellowship, if you will, and we created a Facebook page where we posted all of our pictures. And now with the eclipse coming up, the chatter started to come back up again, saying, where are you guys going? Where are you? People are scattered throughout the whole world, but it's pretty nice to see what their plans are and reconnect after all these years. So this is the picture that I compiled about a month later, showing the corona and all the different phases going into the eclipse, full totality, and after the eclipse as well. And thankfully, it was chosen as in the RAS calendar for next month's eclipse picture so on the 8th. This is a good reminder for me. I have it on my wall, so it's a nice reminder that what we experienced back in 2017. And it's an honor to be in the calendar as well. Finally, this is a process picture of the corona. I tried to get as much of the corona out, and I was surprised at how far it extended beyond the sun. You can see the different jets shooting from the top and the bottom, but I was actually thinking that the 180, the solar disk looks small, but I'm happy I chose the 180 because I wouldn't have been able to capture this level of corona as well. So it kind of worked out, an unexpected benefit on an unexpected journey. And that's it. Thank you. I read that shutter speed was the way to go in terms of being able to get the broader range of the dynamic range of the brightness as it changed. So I was told, not told, I read about this online, that this was other people that had done this, and this would be much better than anything else in terms of modifying any of your other camera settings rapidly at that time. Yeah, what I read was aperture would be better. So yeah, I mean speed, shutter speed. I didn't want too many. Yeah. It's a sharp lens. This is an HDR, so this is multiple images combined. So I took a whole bunch of images of the corona, as I was mentioning earlier, and then I combined them together and created this. Yeah, actually, I am looking into something more automated. This is my first eclipse, so I was like, okay, I'm just doing this for the seat of my pants kind of thing, right? But yeah, I mean, I think, Randy, you mentioned the fact that there was some automated software that you were using. Maybe it's the same thing. Would you need like a laptop with that as well? Yeah. Yeah, I'll try it this time. If I'm going to Niagara Falls this time, we'll see. Yeah, but we'll see. But if I can, I'd like to observe it more rather than worrying about exposure settings. I'll give you a brief overview of how to use our new-ish Lunt solar telescope, hydrogen alpha telescope. Now, I just want to caveat this, but I'm no pro. I've been using it for about 3 weeks now, but I've learned quite a bit in terms of how to use it and the functionality, and some recommendations as well in terms of visual observation and taking pictures through it as well. So I'll go over this quicker than I was planning to, but I won't go over the technical aspects of it so much. We'll just get into the actual visual and the imaging of it and how to use it. So again, quickly, we're looking at the, excuse me, the chromosphere, and a lot of the light coming from the chromosphere is hydrogen alpha, and that's what this telescope is tuned to capture. And the band pass is centered at around, the wavelength is centered at, what is it, 656.28 nanometers. This is kind of what you see through the telescope on a great day, but you'll see a variety of different objects through the scope, prominences, filaments, specules, and plages. And each has its own distinct features associated with it. The most famous are the prominences, which are shooting off the edges there. So this telescope is an 80 millimeter refractor, 560 millimeter focal length. We have a optional Crayford focuser, feather touch, which is a nice addition to it. A sol searcher, which is this item here on top, which you don't have to look directly at the sun through the telescope and blind yourself. Once the image is projected from this side onto here, assuming it's aligned properly, then the sun is usually in focus on the telescope. The eyepiece that comes with the telescope is a 7.2 to 21.5 zoom eyepiece, which helps to zoom in on specific features you want to look at. Although note that once you zoom in on features, the contrast gets a little less as well, so they're not as clearly defined. We have a B1800 blocking filter, which is this piece here. It's what normally everybody would call a diagonal, but this is not really a diagonal. These come in various options. The one that we have right now is B18, which is good for both for viewing and photography as well. And when you get the telescope, you get the scope itself, and you get two other cases. The cases are big metal boxes here. They're kind of hard to lug around, so I brought my own AM5 mount, which does not come with the telescope.
It does now.
Hey. Yeah, exactly. So this is just, I'll go through this very quickly. There's, this is the internal workings of the telescope. You have an objective lens. You have what's called the heart of the telescope is called an etalon, which is two polished optical surfaces, which basically help to filter the light in. Everything is tuned to get it to that specific wavelength of hydrogen alpha, and then it goes then down through to the blocking filter. So visual observation. There may be better ways to do this, but the way I've been using it is that, first of all, you place it on the mount, and for the AM5, you don't have to balance it, but normally you'd like to balance your telescope. The front of it has a lens hood. This whole item here is a lens hood, so you just make this screw loose and extend it, and that'll help it to, dissipate or focus on the light, and there's no ambient lighting coming in. Pointing at the sun, you slew it over if it's already mounted and you already have it polar aligned. What I did in the daytime is I roughly pointed it at the North Star, well, north, and the AM5 is fairly good. It keeps it fairly well in view. You don't have to fiddle around with it too much. So any scope that you have, if it's a polar scope, equatorial mount, align it to the North Star as best as you can, and you won't have to move it around too much. It's 80 millimeters, so it zooms in fairly well. You don't have that much play with it, but it's something to try to do so you can save yourself a lot of time just fiddling with it. One key thing to do is sometimes when you look through it, you don't have enough back focus. So what you do when you first get the scope is you actually physically move it out like this, and that gives you a bit more wiggle room on both sides. So do that, because if you have it up front like this and you're looking through the eyepiece, you might not get the sharp focus that you want. And the same thing for imaging as well. Loosen turn cylinder. So this is the other thing. So this is how you tune the etalon. There's this, let me just kind of move it around. Another reason why you like AM5, it's very light. This is the tuning cylinder for, as Alan was saying earlier, how you focus it in and you can see different features, not really focus, but you can see features on the surface versus the prominences. Now, what Lunt says, and what they advise, is you take this cylinder fully off and don't drop it. And then you thread it back on, and then you start tuning it slowly, very slowly, while observing the sun through this end of the scope. And you will see that I found generally when you tune it, it comes to where it's about 2 or 3 threads showing, that's when you get the optimal view. You will start seeing the prominences appearing at the edges of the sun, and you will see all these filaments and the granulation on the sun as well. So that changes slightly day to day, but that's usually the sweet spot of the scope. So that's basically what you do in terms of visual observation. For imaging, of course, you replace the eyepiece with a dedicated camera. Ideally, you want to use a mono camera because you're more sensitive. But you can just use what you have. You can use a DSLR. There's a way to attach a DSLR on here as well. You basically screw this piece off and you put a T-ring on your DSLR or SLR, and you can thread it directly onto there. Use whatever you have. You don't have to go out and purchase one. I have an older one lying around, so I use that. Turn on your capture software. Either Fire Capture and Sharp Cap are the most popular ones. Brighten the exposure. So this is something that I did here. Brighten the exposure, and you will start to see the prominences at the bottom there. And this is a good way to focus the image as well. You can, not as bright as this, but you want to focus it so you can see a sharp edge on the surface of the sun. Then we reduce this exposure until your histogram, which is down here on the left there, it gets to about 70% here. And as you can see here, now the features are sharp, and you can see some filaments there, you can see the sunspots there, and you can start seeing some granulation there as well. And again, as I said, tune the cylinder so you can get as much features, as much contrast as you possibly can. And then capture video, I'd say 30 seconds at the most, start off with, maybe a minute at the most if you want to go that far. And this seeing everything in astronomy is dependent upon seeing. So nights, as all astrophotographers know. So even in the daytime, days of great seeing, you'll see even more detail. Days of not so great seeing, they won't be as sharp. So you take your 30-second video once it's down like this. Again, I use a 290 mm. It gives you half view, so I have to stitch pictures together. Helpful hints. Rotate the cylinder slowly, as I mentioned. Cover the laptop when you have a laptop capturing the software. Cover it in a Rubbermaid bin or something, so you can see the screen a bit more clear, more contrast. The best camera so far is an ASI 174 mm because it captures a much wider field of view. Experiment with different features. The one filter that I've had, which has helped me in my planetary work and on this as well, is the Batter UV IR cut filter. You can always have an IR cut filter, UV IR cut filter. It takes out a lot of the other ambient light. Keep gain minimal because you don't want to have as much noise in your picture as well. Take flats. We're using a shopping bag. This is what I did. You just put a shopping bag on there, and every camera has some type of defect, or not defect, but like a dust on the sensor or whatnot. This will take it away, and then when you take your shots, it automatically takes those shots without the stuff that's on the sensor. Then use Barlow's and PowerMage to zoom in on the prominences and the little features that you want to see, and of course, have fun, enjoy the ride. One thing I would recommend, if our club has about another 2,000, 3,000 just burning a hole in our pockets, I would recommend to get another Echelon double stack. As you can see the difference here, this is on the left there, but with the DS2, the contrast is increased substantially. You can see so many more features. So I would recommend that, but again, it's not cheap either. Oh, the other thing I'd recommend, it's not on here, is I would recommend getting rings for the scope as well. Because what happens is when the scope is taking a picture, it's rotated all the way down. So you're doing kind of a Stretch Armstrong kind of thing, trying to rotate it. So if you got rings, you can always move it back and rotate it accordingly, rather than just mounting it directly onto the dovetail. So these are the pictures I've happened to take within the last 2 weeks. Again, I'm no pro, but it's a learning curve. But if I can do it, anybody can do it. So you can see the granulation and the filaments here and the sunspots. I captured a prominence at one side of the sun. Not a great prominence, but it was a good starter. On Wednesday, I captured this image because we had a clear day, and you can see the pretty cool prominence on the left there. Kind of more of a complex prominence with the sunspots as well. And then this is the full disk image that I combined from two images of the sun. So it's been a learning curve. There's a lot to learn still, but you can get up and running pretty quickly with this scope. And I would recommend talking to Alan and taking the scope out for a ride. Thank you very much. All with the same tuning. So you don't have to fiddle around with it. Once you get the sweet spot that on that day, then you can just start shooting and bring up the details in several different softwares. And the good thing is a lot of the softwares are free as well. So you can use those. There's one software called IMPPG. It's even better than Registax in terms of the wavelets, whatnot. It's a lot of the solar imagers use that one, and it really brings out the details. Anybody else? Okay, thank you.
This telescope is for, it's a loaner, right?
No, it's mine now.
Yeah.
Oh, that was the agreement for you to
Yeah.
get a talk?
Alan and I.
No, I'm just wondering if people want to borrow it, they can go onto the website, choose it, but is there some training involved for this one?
Yes, although the training that I gave Sheil was fairly minimal, as you can imagine. This scope is by far the most expensive scope in the arsenal. And so we want to make sure that you know the minimum in terms of setting it all over. But also use of it, you know, the sort of thing where you're taking off an expensive component and then you're very, very carefully putting it on and you're extending this and tightening them down. when
Yes,
you forgot to
That
tighten it
was
down.
inferred.
Inferred, yes, yes.
Okay, again, thank you, contributors, and we have a meeting 2 weeks from now. I think our presenter is Robin. Is that not right? This is your Aurora talk? Hey, great. So it's going to be an excellent talk 2 weeks from tonight. It's already done, isn't it? Oh. Oh, okay. I'm sure it'll be excellent.